This puzzle is called Pianissimo by Yttrio. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look at the rules. So the green lines are German whisper lines. Consecutive digits along the line must differ by at least 5. So if we found out that this was an 8, then the digits next to it must be differ from the 8 by at least 5, so 1, 2, or 3. If we tried to make one of these a 4, that's a difference of only 4. 8 minus 4 is 4, of course, so that wouldn't be enough. We need to have it be at least 5, so it could be a 3. And digits can repeat along the line, so these could both be 2, but of course they can't repeat in the same column, row, or region. So we couldn't then make this another 8, is what I mean. But these two being 2 is just fine. Yeah, and then the other thing, cells separated by black dots have a ratio of 2 to 1. Not all black dots are given. So these two black dots have a ratio of 2 to 1. That means one of them is double the other one. So if this was a 3, we can't put 1.5 in here, so this must be 6. If we found out that this was an 8, this would have to be a 4 because we can't double 8. If we found out that this was a 4, this could be 2 or it could be 8 because we can have 4 and we also can double 4. So there's some options there. Yeah, I think that's all the rules. So I'll put a link to in the description, not the link to the description. That's pretty easy to find. I'll put a link in the description to this puzzle if you want to give it a try yourself. I think this might be on the easier side, but I really don't know. I like the theming, and I also wanted to get some practice with German whisper lines. So yeah, there you go. Let's give it a try. So the first thing I see is these black dots. When you have a string of these black dots, there's only 2 options for it when it's when there's 2 black dots in a row like this. It could either be a series, and of course this could be, it's symmetric, so it could be going upwards or downwards, but it could either be 1, 2, 4, and this obviously 1 or 4, 2, 1 in the opposite direction, or it could be 2, 4, 8. So those are the only 2 options, because 3 and 6, well, then you're gonna have to repeat the 3. You can't double 6, so it would have to go back to 3. And 5, 7, and 9 can never appear on a black dot because you can't have them and you can't double them. So the only options are 1, 2, 4, 8. And in fact, the middle digit always ends up being a 2 or a 4. And 2 and 4 both are used along this sequence. So, yeah. And now that's going to, I think what that's telling us is, oh, what is that telling us? I thought I saw something, but I'm not sure. Well, there's a lot of things going on. So, um, the first thing I guess we should cover is that you can never put a 5 on a German whisper line, because to get a digit that differs by at least 5, this would have to be a 0 or a 10, and neither of those are valid digits. So we can never have a 5 on a German whisper line. So if we look like over here, in box 4, 5 must go down here. In column 2, 5 must go down here. In column 5, sorry, did I say 2 must go down here? I meant 5 must go down here. In column 2, 5 must go down here. I think I got 2's on the brain there. In column 5, 5 must go in one of these 2 cells. Ooh, that's not as helpful as I thought it would be. Okay. And then 5 in box 6 must go in one of these 2 cells because it can't go here because of the 5's looking over. Oh, but what about box 5 itself? Theoretically, these 2 cells, but we have this pair looking over, so that can't be a 5, and this must be a 5, which means this can't be a 5, and this is a 5. Okie dokie. So we have a couple digits going. No, we have 3 options for 5 here and 3 options for 5 here. Okay, the other thing to realize is that digits kind of do this oscillation thing along the line. We just stated that 5 can't be on the line, but whatever, I'll say the word polarity, but if this is either a high or low digit, this is either a 1, 2, 3, or 4, or a 6, 7, 8, or 9. Let's say it's a 4. Then this digit is going to be a high digit. And then this digit is going to have to be a low digit. And then this is going to be a high digit, low digit, high digit, low digit, high digit, because say this is the 4, this is the 9. Now what's the minimum, or what's the highest this could be? Well, 5 away from 9 is 1, 2, 3, or 4. We can't go up to 5, and 6 is only 3 different. So each time we're going to oscillate to the opposite side of 5. So this is going to be another low digit. And then even if this is a 1, we add 5 to it, that's already up to 6. So that's going to be another high digit on the opposite side of 5, which is then going to need another low digit, and so on. Now we don't know if blue is low. We don't know if blue is high, but we know that blues and pinks are at the opposite sides. Maybe we'll change this to yellow. How does that look? I don't know. I do like coloring 5s gray as well. So, we do know one other thing. We can't, no, we don't know that actually. Never mind. Never mind. Ignore me there. Maybe we color this over here as well. Now, we don't know if we shouldn't use these same colors because we don't know. Not only do we not know if any specific digit is low or high, we don't know if its lowness will match the lowness on this side. So let's use let's use blue and hot pink. So this is blue. These are all blues because they're one away from this. Yeah. And this will be a blue, then this will be a blue. And these will all be hot pink, and that one, and this one. That's not hot pink. This is hot pink. Okay. So here's something I can immediately tell. Light blue is equal to yellow. If light blue was equal to hot pink, then there would be 5 either high digits or 5 low digits in this row, which is not possible. You only can have 4 high digits or 4 low digits in a row. So we know that light blue is actually equal to yellow. So let's just change that over to yellow, and that means the opposite of light blue, this hot pink, must be the same as dark pink. So now we figured that out. And now we can actually do a good important step here. So this line here is going to have 1 yellow and 1 hot pink. One of each. That is 4 yellows in the row. So now we have 4 yellows in the row. We have 3 pinks in the row. What is 2 and 4 going to be? It must be a hot pink as well, which means hot pink is a low digit. And now, just for my own sake, I'm going to recolor all of hot pink to not be not be dark pink. It's going to be dark blue. And let's keep yellow. That actually looks kind of nice. In my mind, I always think of the pink as the high digit or the odd digit, and so having it be the low digit messes with my mind a little bit. So I don't want to do that. So we know these are the low digits. So all the blues are low digits. The yellows are high digits. So let's see. What can we do here? Well, we know these are all the digits here, 1, 2, 3, 4, and now because those are all literally all 4 of them are highlighted. And one thing that's important to notice is that 4 is really hard to place. 4 and 6 both. Let's say if we tried to place a 4 here, well, what's the only digit that's 5 away from 4? That's a 9. That means all 4 of these would need to be a 9. Well, that's definitely not going to work. That would be a lot of 9s. So this can't be a 4. What about this? If we try to make this a 4, both of these would be 9. That also doesn't work, so this can't be a 4. What about this? Could this be a 4? Well, then both of these cells would have to be a 9, and that would be 2 9s in the column, so that doesn't work either. So now we have a 4 here, and now we can place both 9s. Now, unfortunately, 9 is the most, accepting of low digits. It can be next to all of the low digits, so that doesn't help spectacularly much, but it does help a little bit. Oh, and actually, where can we put 4 in this column? We've already ruled 4 out of these two. could we put a 4 here? We've already put in one 9, but we can't make this a 9 as well. So it turns out we can't put a 9, sorry, we can't put a 4 on the line in column 2, so that means the 4 is going to go down here with the 5 and make a 4-5 pair. Yeah, okay, that's a good place to look. Okay, so I said 4 and 6 were both very restricted. Let's look at this. Let's look at 6 in column 2. If we made this a 6, what's the only digit 5 away from 6? That's 1. Basically the opposite situation as 4 and 9. So both of these would be 1s, and that's not going to work. So this can't be 6. What about this? Well, no, it has 3 digits that are next to it, so those would all be 1s. That's not going to work. It can't be down here, so it must be right here. Does this actually work? Just barely. Since the 1s don't see each other, they can both be 1s, and that figures that out. So that's good. Now this cell is next to a 2 and a 3, which means it must be an 8. 3 can only be next to 8 and 9. So because it's next to a 3 and it can't be a 9, it must be an 8. And then this cell is a 7 or a 6. Because it's next to a 2 or a 3, it's not next to both necessarily. It can't be the 6, must be the 7, which makes this a 2, because 7 can only be next to 2, can't be next to 3. And now we have these digits all arranged a little bit. Okay, let me just see. This is a 7 or an 8. Okay, that's not 2. This must be a 7. That's good. That's very helpful. That's the last high digit in the column. We just need to place the 7 somewhere, so that's the place that it goes. 7 can only be next to 1 and 2, so that must be a 1-2 pair. And then we have a 2 and actually, we have both a 2 and a 1 looking up, helping us figure out the orders of those. Okay. We have a 2 and a 4 looking over here, so this can't be a 2 or a 4, which means this must be the 2, 4. Those are the last 2 spots for the 2 and 4. Now, unfortunately, we don't know the order yet. This could be 1, 2, 4, or 8, 4, 2. Both, at least at a surface level glance, seem to be working, like both would work. Yeah. What about here? This is a very weird, like, just the interconnectedness of this. But I'm not sure if I can figure out anything about it yet. Let's take a look at this longer line. So this is a 1 or a 3, because it's a low digit and it can't be a 2 or a 4. Oh, if we could figure this out, that would tell us what this is. Because if this is a 1, this is an 8. If this is a 3, it's going to put 8 and 9 next to us. They're next to it, not next to us. Next to it, which would then also tell us about this cell. Yeah, I'm not sure I know which way around it could go. Let's see, these unfortunately are offset just slightly. What about this? This could be 1, 2, 3, or 4. Oh, what about this? This must be a 1-6 line. Yeah, the last high digit in the row is a 6, which must go on this line. 6 must go with 1, so this is going to be a 1-6, which makes this a 3, which is going to make this an 8-9, like I talked about, which makes this a 1, and this must be a 2-4, like this. Okay, so this is another low digit, so both of these are high digits, which makes them 6 and 7. Those were the last high digits in the box. What's left here? This must be a high digit as well, because we already have all 4 low digits and the 5 in the row. Oh, we have a 5, 6 here. So this is just a 7. This is a 6. This is a 7, 8, 9. Okay, that's fine. Actually, this can't be a 7 or an 8. Yeah, what digit is this? That's the easiest way of looking at this. This must be a 4. It's the last digit left in the row fully, so that must be next to a 9. Makes this an 8, 9. Makes this a 7. Oh, I didn't actually color this yet. I should do that. So this must be a 1 or a 2. This can be a 1, 2, or a 3. This could be a 1, 2, 3, or 4. Well, that's not as helpful. This is 6, 7. Whoops, 6, 7, or 8. Not that one. Just this one, because it sees a 9 up here. This is a 6, 8, or 9. It couldn't be a 6 because both of these would have to be a 1. In fact, this cell must be a 3 or a 4 since it sees 1 and 2, so this must be a pretty high digit. Okay. So what's left over here is 2, 3, and 8. 8 must be one of the digits on the line, because if this is a 2, one of these two digits is going to be the low digit. The other one is going to be the high digit, which must be an 8, so this can't be an 8. The 8 must go on this line. Although, I don't immediately see how we can figure out which way around it will go. That does seem kind of like what I need to look at next. I'm not seeing much else. Um, hmm. Maybe I need to look at this. I know one of these is a 5. Have I done anything with that? No, but I don't see what I could do with that either, so that doesn't help all that much. So these two digits are going to both be high or both be low. If these are both high, that would be all the high digits in the column. But that also seems fine. This is going to be a high-low pair as well, of course, because they're adjacent digits. We do have a 6 ruled out, but 6 couldn't be there anyway. Maybe there's just some basic Sudoku we can do. So 4 is in one of these two cells because it can't be along here in row 1, or in column 1 because of this 4. We already have the 4 down here. Let's see. If this is 8, this must be 3. This is 8, this is 8. That doesn't really seem to help that much. Maybe I think I need to figure something out about this German whisper line here that I'm just not quite grasping yet. Yeah, I mean, there's something about this that I'm not understanding. Oh, okay, here's something. Where does 2 go in box 7 here? This must be the 2 because 2 is ruled out from column 3. Oh, this can't be a 4 because this can't be a 9. So this is a 1, 2, or a 3. Sorry if you can hear my chair. Every time I move, it squeaks. It's a very loud chair. Oh, 7. Where does 7 go? We have a 7 looking down here. So this is a 7. So the digit in here is an 8 or a 9. The digit in here is an 8 or a 9. Oh, what's left here is 3, 8, 9. So we have an 8 or a 9 in here. This is 4, 5, 6 because that's all that's left in the column. I'm trying to think if there's some way I can use the fact that there's all these, like all these 8s around here. But I don't quite see how to do it. This is tricky. There's something here that I'm just not quite grasping. So if this is a high digit, this is an 8 or a 9 because it sees 6 or 7. That makes these high digits as well. So this is an 8 or a 9, this is an 8. This is a 7, 8, or 9. It can't be a 6 because that would put two 1s in the same box. So it would be 7 Or couldn't be an 8 either, so 7 or 9. Why is that a problem? I'm not sure. But what if this was the high digit? This is still 8 or 9. This is an 8. This would have to be 9. Oh no, that would break it. That breaks it. Okay, I see it now. It's not as hard as I was making it out to be. So if these two digits were high digits, this must be an 8. Okay, now this must be a 9 because of the 8 in the column. So now what is this digit? We've already used 8. There's 7, 8, and 9. So this must be a 6. But we've said a couple times we can't put a 6 on this line because we'll put 1s in both of these spots. So if we make this a high digit, it makes this a high digit, which now puts too many high digits in the column and forces a 6 onto this very restricted line. So these are, these are the high digits, which makes this an 8, this not an 8, this an 8 or a 9, this a 7 or a 9, if I recall correctly, because it can't be an 8 and it can't be a 6. So this is a low digit. Actually, all of these are low digits. Let's just color it like that. 1, 2, 3. This is 1, 2, 3 as well. It can't be a 4 because both of these would then be 9. We now have a 1, 2, 3 triple, so this is a 6, this is a 1. What's left in the column is 4 and 5, which does give us a 4, 5 pair down here. So 5 is ruled out there. That's not super helpful. Okay, so if this is a 3, this is an 8, 9, and that works just fine. Just one of these is a 9. Let's focus. I was gonna say let's focus on Sudoku, but I think that's all I really have left. I think these two very short lines are just gonna kind of disambiguate the very end. So it must be. I think it must be Sudoku. Although maybe we could figure something out with these lines. Oh, this can't be a 1. We have a 1 right there. And this can't be a 1 because we have a 1 right there. So I guess one of these is a 1? Is that correct? This 1 is looking down. It can't be anywhere in here. So these are 1s. So now we have 1s looking up to box 2. This must be a 1, which means this is not a 1. Well, that's not super helpful either. 1 doesn't really put any pressure on the high digits. It's the most accepting of the high digits. This is a 3. This is an 8, 9. This is a 9 because this is a 4. Which makes this a 5 and this a 4. I don't see a problem with any of that. This is a 5 or a low digit, I'm seeing. A 5 or a low digit. Because it sees 6, 7, 8, and 9. So this is a 1, 2, 4, or 5. I don't really like that coloring. Let's get rid of that. Because one of these is a 4, right? Because 4 can't be anywhere up here, and we have this 4 looking down. So one of these is a 4. There's a couple ways of getting through this. We have the 4, 5 pair, or we can just say we have the 4s pointing over here. So this is a 5. Which makes this and this a 4. Which makes this a 5. So this must be a 5 then, because that's the last spot in the box for a 5. Which makes this the 1. Means this can't be a 5, so it's a low digit. Oh no, we don't quite have enough there. These two are opposites, but that doesn't quite help. This is a high digit, so this is a 6, 7, or 9. We have 4 looking over here and a 4 looking down. This is the last spot for a 4. So one of these is a 4. If this was a 4, this would be a 9, and we have a 9 in the column already, so this can't be a 4, which is going to finish off our 4s. And actually, there's a 5 right here, so this can't be a 5 either. This is a 6, which is going to give us a couple more digits. Nice. Yeah, okay. The middle column is all paired up. Just seeing if there was any offset digits, like, I don't know, if this was 2 or 4, then no, that'd be very easy to figure out because we've already placed the 4 in the column. Sometimes, scanning like that will get away from me, so gotta double check. What's left over here is 3, 5, and 8. This can't be a 5, and that's all that helps. Okay. Um, no, we don't. This is not paired up as much or at all. This can't be a low digit. This sees 1, 2, 3, and 4. So this must be a high digit. This must be a low digit. So this digit could be 2 or 3. So this digit is 7, 8, or 9 because it can't be a 6. A 6 would put a 1 here, and we have a 1 in the row. And it can't be 8 or 9 because we have an 8 and 9 in the column. So this is a 7. That makes this a 2. Which is actually gonna help figure out a lot of these digits, or a couple of these digits at least. Oh, this 2 is gonna make that a 3, which is gonna make this a 1. Unfortunately, the 1 doesn't give us any information about here. Oh, this must be a high digit. And this must be a high digit. Because we've already put all the low digits and the 5 in the column. So this is an 8 or a 9, and this is an 8 or a 9, which makes this a low digit, which can't be a 1, can't be a 4, so this is a 2 or a 3, which pairs up the 2, 3, so these are both high digits. Because we already have all the low digits, and we already have the 5, so these must be high digits. Make them not 9, so 6, 7, 8. We have an 8, 9 pair there, so it's just a 6 or 7 there. 6, 7, 8 here. A little bit of information at least. This 8, 9 pair means that this isn't an 8. One of these is a 5. One of those 4 cells is a 5. That's not helpful. Okay, let's... Can we put a 2 in here? No, we can narrow it down to just 2 spots. What about 1? Oh, 1 is going to be narrowed down to the same 2 spots. So we have 1 and 2 looking in column 9, and 1 and 2 looking in row 2. So none of the H can be 1 or 2, so these both must be 1 and 2. Those are the only spots left for the two numbers. And let's look at this column. What's left is a 5 and a 6, it looks like. This needs a 5 and a 6. Yep. 4 then must be in one of these 2 cells. Oh, and this, yeah, we have 4s looking into box 2 from both left and right, so this must be the 4, which makes this a 9. Nice. So this is the 8, this is not an 8. I kind of imagined that helping more. Oh, now we have 8s looking up, so this must be an 8, because it's the last spot in the box for an 8. This must be an 8 as well, because we have the 9 looking over. This 8 makes this a 9, which makes this a 6, 7, 9. These can't be 9s, so this is a 9, which is a high digit. Still can't... Oh, no, we have a 3 now. We have a 3 now. Never mind. I was going to say we still can't figure those out, but we can. I just didn't notice it right away. Okay. Whoops. Meant to get rid of the pencil mark, not add more. This is a 3 based on the row, and this is an 8 based on the row. These are low digits. What's left here? I guess what's left in this... Oh, there's a 7 looking up. Maybe that's the easiest. So 6, this is... Whoops, not that. That's not a 5. This is the 5, which looks back down to here. Oh, and we have this 1 here, so this is a 2, 1. This 2... Oh, this 2 is looking... Whoop, this 2 is looking up, which makes this a 2. This 3 is looking up, making those situated like that. This must be a 3 because this 3 is looking over, which is gonna finally figure out this box 1 a little bit. This is a high digit, this is a 5, this is a high digit, and a 7. So this is the 7, this is the 9. Whoops, I literally said this is the 9, and then I just typed a different digit. There we go. That was a nice puzzle. I really liked that. It was not terribly difficult, but I'm not a very good German Whisper solver, so I think that matched up nicely with me. I was a bit slow, noticing that both of the high digits would have to be 8 and 9, which would rule this out. But other than that, I think I did pretty well. Solved pretty quickly along this line, or along this puzzle. So, yeah, thank you very much, yttrio, for this puzzle. I enjoyed it quite a bit. And thank you all for watching.